But for now, we'll move on to the very last talk of this workshop for today. And that will be by Gordon Chin. And he will talk about the confirming orbital remote sensing with ground information experiments consortium, or the CORGIE consortium.
Thank you. I hope that you can hear me.
Yes.
You can hear from the theme of this entire workshop about the volatiles and the ambiguity of some of the observations about the volatile transport and the environment in which we are looking at. This is what motivated this consortium in order to try to remove some of these ambiguities from orbital remote sensing observations that had in the past, continuing and planned. So next slide, please. So the CORGIE consortium will try to say that a suite of experiments that you may have heard about already in the workshop, in particular ESOV, Sniffler, and CLUMI, we include one extra instrument, Rockstar, will be a comprehensive set of experiments that on the surface can help us look at some of the most important information and observations and themes that this workshop has been working towards. In particular, we want to see what the exosphere is and to characterize this time-varying water content in the moon's exosphere on the surface and near the subsurface with the suite of instruments such as ESOV, Sniffler, Rockstar, and CLUMI. I am not going to go back and tell you about the particular specifics of each of these instruments, except to highlight their strengths and their complementary nature and some subtleties of what we're talking about. So we'll start with the next slide, ESOV. As Tim Livengood has stated in his talk, ESOV is a sub-millimeter high spectral resolution spectrometer that will look at H2O and OH. And it's very important to note that we're looking at H2O and OH simultaneously in the column from the surface of the moon to the sun. We are using the sun as a background radiation that provides incredible sensitivity because of the 1,000-degree that we have in which we could see the absorption lines of H2O and OH. We are looking at these simultaneously so we could get all the type of species or variation of H2O as in the exosphere. H2O may be volatilised into OH. So we would have a complete column against that. We also want to emphasize that ESOV is in the second year of its DALI program, and by the in TRL 6. The next slide, please. Tim also talked about Sniffler, and what Sniffler aims to do is to measure the content of water or hydrogen in the subsurface on the surface of the moon within about a meter length of depth. And I would just like also to reemphasize what Tim has said on Sniffler, that there are variabilities in systematic processes which are variable in the just measuring the epithermal neutron flux. This has to be really calibrated away so that the GCR variability, which is the source of this epithermal neutron flux, can be also recognized and taken away. So I just want to emphasize that the combination of ESOV and Sniffler will give us the hydrogen water concentration from 1 meter below the ground to the exosphere itself. Because ESOV actually uses the sun as the background radiation, there's a slant distance. The measurement of the column density measured to the sun also covers a wide latitude range. range so that the actual landing site is not important. So I'm just going to bypass the other two slides and go to the last one, which tells the story of why we think CORGIE makes so much sense. The last slide, please. So this makes use of various methods to sense the abundance and location of water and important species using active and spectroscopy. And you could see that we can, I think, really have a very robust and complementary way of detecting the water environment, and most important, if there is a time varying component to that water abundance, these set of observations will reinforce each other because I think there's such
Gordon, you're about 30 seconds over time.
Okay, thank you very much.